Okay, in this video I'm going to continue with exercise 1b and I'm going to do question 5 of Fundamental Applied Mathematics. So here's the question at the bottom there. Find unit vectors in the same direction as these, and it gives you two vectors. Now, to be honest, I think that question is quite vague, so just bear with me while I do a small bit of thinking here. I'm going to say that the vector A is equal to what? It's equal to 3i hat plus 4 times j hat. And as normal, we got to do the following. We've got to draw our xy axis, otherwise known as our Cartesian plane. To define our unit vectors here, I hat, j hat, okay? And let's draw the vector A. So it's 1, 2, 3 units in the I hat direction, 2, 3, 4 units in the j hat. So we'll say it's approximately here, okay? Now, we've got to drop our perpendiculars. Now, what you should realize, well, hopefully you've realized that dropping perpendiculars is actually the same as finding the component vectors of this resultant. So this vector here, A, is a resultant vector. It's made up of other vectors. What I've done here is I've broken it up into two vectors. So I've done the opposite of adding. Whereas usually you would have been given, we'll say, this vector C and the vector D, and you would have went C plus D is equal to dot dot dot, and it happens to be that C plus D is equal to 3i plus 4j. Okay, 3i plus 4j, and as I said, A is equal to 3i plus 4j. Alright, so anyway, that's how we do it. Just going to give their magnitudes. C is equal to 3, D is equal to 4. Now you can do a bit of Pythagoras here, and you'll find that this is 5, because remember that the hypotenuse squared is equal to the square is, sorry, not the square root, is equal to 3 squared plus 4 squared, and you get the square root of that. So I'll just do it anyway. So you get 9 plus 16, which is 25, and you get the square root of 25, which is 5. Okay, I hope that makes sense to you. There it is explicitly for you by Pythagoras, P-Y-T-H. Okay, so anyway, it says find unit vectors in the same direction. Now if you're looking at what direction, well, you got to find the angle at which these vectors are. So I'm going to find this angle theta here, so I'm going to use, of course, the usual stuff, sec Torah. So we could use a multitude of things. This time I'm going to, just for a crack, go for tan theta is equal to what? It's equal to 4 over 3, opposite over adjacent. Therefore theta is equal to inverse tan 4 over 3. Or arctan, that's the same thing, equals what? Let's find out what it equals. So inverse tan of 4 divided by 3 is equal to 53 degrees. 53 degrees. So the question is, find unit vectors in the same direction. So basically we're asked to find it as any vector that's at an angle of 53 degrees. So how do you go do that? To be honest, I think, now I'm not 100% sure about this, but I'd be surprised if I'm wrong. And either way, this question is phrased quite poorly. So anyway, the usual stuff, this same unit vectors is up here. Alright, and we know that we want a vector at 53 degrees. And that's all we want. So it could be anything. Like there literally is an infinite number of vectors which will give you that angle. So you can pick any of them. So let's try one of them here. So just for the crack, drop our perpendiculars again. In other words, get our component vectors of this one here. And what we know is that what we want to find out. Say we'll call this the opposite. We call this the adjacent. So we'll say tan 53 is equal to O over A. Alright? Therefore 53 is equal to inverse tan O over inverse tan O over A, or, well, that actually did me no good. So we'll say tan 53 is equal to opposite over adjacent. Well, what's tan 53? Tan of 53 is equal to 1.32. So opposite over adjacent is equal to 1.32. Therefore the opposite is equal to 1.32 times adjacent. And that's all that seems to matter. Opposite is 1.32 over adjacent. So you could say that the opposite, you could say A is equal to 1 and O is equal to 1.32. You could say A is equal to 2 and O is equal to twice 1.32. You could say any of those and they all match. Now the thing is, in the book you're given an answer. The answer in the book that's given is 3/5 I hat and 3/5 I hat plus 4/5 j hat. Okay, that's the answers given in the book. So what I'm going to do very quickly is see if that gives me the same angle. 3/5 I hat plus 4/5 j hat. So the same stuff, same unit vector as the past, y, x. So we have 3/5 I hat and we have 4/5 j hat. I'm going to move slightly quicker now than I would usually, so I'm going to call this theta. So sine theta, wrong, tan theta is equal to 4/5 over 3/5. Therefore theta is equal to inverse tan of 4/5 over 3/5. So theta is equal to inverse tan of 4 over 5 times 5 over 3 is equal to inverse tan of 4 over 3. So let's have a gander and see what that is. Inverse tan 4 over 3. Well, it's tan 4 over 3. Inverse tan 4 divided by 3 is equal to 53 degrees. So, yes, that was a question phrased very poorly, but there are any number of answers to that question.